Welcome to everyone. Today we move on to the next part of D block elements, the formation of colored ions. Dear friends, you keep in your mind that transition metals are always colored in either liquid, means aqueous form, or either itself is in a solid form. Means transition metals always shows an colored either in liquid and solid, except some metals like example zinc, mercury and some cadmiums. They are shows a maximum different variation of colors. Why these transition metals shows color? That is the major reason of our syllabus today. The transition metal shows color because they containing maximum number of unpaired electrons. This is the answer. Already we know every question having a single answer because of unpaired electron. Here also, why they form a color or shows color, the maximum number of unpaired electron. So dear friends, you keep in your mind, yes, the transition takes place in a d orbital, the lower energy to the higher energy within the d orbital. Within the d orbital, so always the energy gap is very less. D orbital nalle electronಗಳು lower energy ಇಂದ higher energy ಗೆ jump ಆಗ್ತದೆ, excitation ಆಗ್ತದೆ. At a certain time they start to emit radiations. Those radiations are visible in the visible region by using complementary color. Those shows different colors. ಅದರ ಯಾಕೆ ಕಲರ್ ತೋರಿಸ್ತದೆ ಅಂದ್ರೆ d orbital ಅಲ್ಲಿ unpaired electronಗಳು maximum ಇರ್ತದೆ. Those electrons easily jump from lower energy to the higher energy. Why, sir? The energy gap is minimum. The energy difference is minimum. Idu bala short distance alli irodrinda this electron can easily shift from lower to the higher. Obviously, at that moment the electrons emits the radiations, and those radiations are visible in the visible region with the complementation or complementary. They shows colors, friends. Yes, I start with the example why how these transition metals, their ions shows different colors. A very interesting part, friends, is that a component is available is a scandium. Scandium can exist, I think all of you know, is in a +2 and +3 oxidation state. Scandium available +2 and +3 oxidation state. Yes, let us begin with the scandium. Atomic number is 21. Electronic configuration argon, 3d and 4s, the 2 electron, and here it is a 1. S in d orbital, they have only 1 unpaired electron. S having 2 unpaired electrons. And due to this unpaired electron, keep in your mind, they can choose colors. Yes, therefore, scandium +2 means loss of these 2 electrons is electronic configuration argon 3d1 and 4s2. Sorry, 4s0, not 2, 4s2. So now N stands for 1 unpaired electron. Due to 1 unpaired electron, they are colored. Unpaired electron idre makkale color torisutte. Ade ನೀವು scandium +3 ತಗೊಂಡ್ರಿ ಅಂತ ತಿಳ್ಕೊಳ್ಳೋಣ. In scandium +3, argon 3d and 4s, removal of all 3 electrons. This is also 0, this is also 0. N stands for 0. If N stands for 0, there is no unpaired electron. The component is colorless. Or certain cases they can use white also. Colorless means is a white. We come to the conclusion. Yes, formation of colored ions. Yes, the removal of outer electrons with different oxidation state is easily available. We know the variable oxidation states. And in variable oxidation state, yes, +2 can of scandium shows color because it shows 1 unpaired electron. Yes, scandium +3 can shows 0 unpaired electron. It is colorless. This is the simple concept of coloration of the transition metal. In as our syllabus, they mentioned the 2 questions. Why copper +2? Why copper +2 is color or colorless? You can find the answer. Copper +2 is color. Copper +1 is colorless. Is why copper plus 2 is color, copper plus 1 is colorless. We know the answer, friends. Copper is 29, argon 3d10 and 4s1. Copper plus 1 stands for loss of 1 electron. So argon 3d10 and 4s 0. Therefore, n is equal to 0. There is no unpaired electron here. N equal to 0. This is colorless. Banna illa sir. If you consider the copper plus 2, argon, to remove the 2 electrons, 0 here it becomes to 9. 9 stands for 1 unpaired electron. 9 ಆದರೆ 1 unpaired ಇರುತ್ತದೆ. Therefore, yes, n equal to 1. Yes, so it is color, especially it is a blue color. And this is also an answer. Scandium, you consider in a copper. If you want to take another best example of our syllabus is zinc, friends. So many times they ask this question: why Zn plus 2, zinc plus 2 is colorless? Very simple. The same zinc atomic form is 30. If you use 30, argon 3d10 and 4s2. Plus 2 stands for loss of 2 electrons. Argon 3d10 and 4s0. D10 system. Due to this reason, D10 n is equal to 0. If n equal to 0, the compound is colorless. This is very important for 2 marks. If this question will ask for 1 mark, if having so many in competitive exam, direct answer, yes, you can use, yes, why zinc plus 2 is colorless? Because the reason is D10 system. In ಬರೀತೀರಾ ಯಾಕೆ zinc plus 2 colorless ಇರ್ತದೆ ಅಂದ್ರೆ ಸರ್, it is having a D10 system. ಇಲ್ಲಿ ಬರುತ್ತೆ ಮಕ್ಕಳೇ, ಸರ್ copper 1 and copper 2. Sir, why copper 1 is colorless? Because this is D10 system. Sorry, D10 system. Copper 1 is D10 system. Why this is a color? Because it is a D9 system. And this is the major concept of color of transition metal. I repeat, friends, why transition metal form the colors? Transition metal itself is a color either in liquid medium or either aqueous medium or either in solid medium, because they contain maximum number of unpaired electrons. Those unpaired electrons can undergo excitation from lower energy to the higher energy of the same d orbital. Than orbital alle taanu excitation aagtirtade makkale, and due to this time they emits the radiation that can visible in visible region with different colors. Keep in your mind final conclusion: D block ಎಲಿಮೆಂಟ್ಗಳು ಏಕೆ ಬಣ್ಣಗಳನ್ನು ಕೊಡುತ್ತವೆ ಅಥವಾ ಅಯಾನ್ಗಳು ಏಕೆ ಬಣ್ಣಗಳನ್ನು ಕೊಡುತ್ತವೆ? ನಮ್ಮ ಉತ್ತರ ಫಿಕ್ಸ್ ಅದ, ಬಿಕಾಸ್ ಆಫ್ unpaired electrons. As maximum number of unpaired electron, the color sharpness becomes to the maximum. ಎಷ್ಟು unpaired electronಗಳನ್ನು ಕೊಡ್ತೀರಾ ಅಷ್ಟು ಶಾರ್ಪ್ ಕಲರ್ ಬರ್ತದೆ. ಈಗ ಎಕ್ಸಾಂಪಲ್ ಹೋದ್ರೆ ಮ್ಯಾಂಗನಸ್ ಪ್ಲಸ್ 2, Mn plus 2 ದಲ್ಲಿ ನೋಡಿ 5 unpaired electron, it becomes a very highest purple color. So this is the very interesting question in annual examination. I will give the question also: why copper 1, copper 2, why zinc, why scandium, or it shows the colors or colorless. You keep practicing with the different example. Yes, the answer you keep in your mind. If you get the n values is a number, is becomes to the color. N values becomes to the 0 is colorless. Okay, and in the next video, friends, we move on to the next bit of our syllabus: why D block or transition elements are good catalysts or either they form a good complex formation. Okay, thank you so much for watching.